important topic, especially the students who are from computer science engineering or an information technology, or the students who are going to write any of the placement related papers, any student who is going to prepare for GATE examination, any student who is going to prepare for GRE, any student who is going to prepare for CAT examination, any student who is preparing for Staff Selection Commission examination, where there will be certain number pattern questions that will be formed, that can also happen, and a student who is preparing for bank related exams, and also the students who are preparing for CLAT and IPM. This is one topic where most of the teachers hesitate to take this topic because they think this topic does not have any of the conceptual clarity. But according to me, this is one such topic. If you understand it, you can probably understand a compiler design very beautifully. So keeping into consideration the engineering students who are sitting in home and going through an engineering classes online, students who aim to get into GATE examination, students who plan to get into GRE examination and any other examinations, this will be there. Base system. What is a base system? What is the weightage of this topic? Base system. The weightage in any of the competitive examinations is minimum 2 questions or maximum 4 questions. Out of entire paper, this is the weightage of a particular topic. This is an extremely important topic. If a student has got a number system as a topic which is tested in your aptitude examination, if you got number system as an important component in your aptitude syllabus, this topic is extremely important. Now, what is a base system? What is a base system? How important is to know this base system? Now, base system. Base system is nothing but a system which represents a number, by using only few digits. If you represent a number by using few digits only, then that system is called a base system. In other words, in simpler language, base system, a system which has got some base attached to it. That base is use only these digits. Use only from this digit to this digit. Do not use any digit beyond this digit. If you are putting a restriction on a particular set of digits, then that system is called a base system, which is called a base system. Suppose, for example, there is one water bottle with me, right? So, how many water bottles are there with me? One. This water bottle is nothing but a numeral. Numeral is something, right, which can be seen, which can be touched, which can be felt. If I am giving a value to that numeral, that is nothing but a digit. If I am representing a number by using only few digits, then that system is called a base system. For example, I decided to use only digits 0 and 1. Only digits 0 and 1. I am using only 2 digits. I decided to use only 2 digits. Suppose a switch. Only there are 2 things, either on or off. So, a flip-flop, which is an on state or an off state, digits 0 and 1. I decided to use only 2 digits. 2 digits. I am using only 2 digits. I am only using 2 digits. 2 is nothing but binary. Then that base system is called a binary system, which is called a binary system. What is a binary system? A binary system is a system which uses only 2 digits. What are the 2 digits that I am using? 0 and 1. Why it is 0 and 1? Because in a computer architecture, 0 is considered to be an off state and 1 is considered to be an on state. So in all these base system, we will start from a digit 0, which virtually represents that it is an off state. So if I use 2 digits, it is called a binary system. Now, if I decide to use 10 digits, if I decides to use 10 digits, and all the digits should start from 0. So I will use from 0 to 9, 0, 1, 2, 3 and so on up to 9. If I am using 10 digits, 10, 2 in Greek is nothing but bi. 10 in Greek is nothing but deca. Deca is 10. So this system is called as decimal system. A decimal system. A decimal system. Decimal. DEC, it is nothing but 10. MAL, which is nothing but 10 digits. A system which uses only 10 digits is called a decimal system. A system which uses only 2 digits is called a binary system. Similarly, a system if it uses 8 digits, because it is 8 digits, I have to start from 0. So I will use from 0 to 7. 8. 8 is nothing but octa in Greek. So it is nothing but an octal system. Octal system. Octal system is a system which uses only 8 digits. Binary system is a system which uses only 2 digits. Decimal system is a system which uses only 10 digits. If I am using only few digits to represent a number, then that system is called a base system. Then that system is called a base system. Now if you see, suppose another important type, generally if you take our computer, it has got a restricted size, but the kind of programs that we execute are beyond the size abilities. So we have to use more digits, but we cannot specify more digits. So we use alphabets. Suppose if I use from 0 to 9, there are 10 digits which I am using it. 10 digits which I am using it. So I will use some alphabets to represent. A is nothing but 10, B is nothing but 11, C is nothing but 12, D is nothing but 13, E is nothing but 14, F is nothing but 15. So how many alphabets I used? 1, 2, 3, 4, 5, 6. 6 alphabets I am using. That means 0 to 9 I am using 10 numerical values, 10 numerals I am using, and I am also using 6 alphabets. 6 alphabets. So 10 plus 6 total 16 numerical and alphabets which I use, which I call it as an hexadecimal system. Hexadecimal system. All engineering students pay little extra attention to it. Definitely 2 marks you will get it, and these 2 marks can be solved in less than 1 minute if you understand this idea. Hexadecimal system. Hexa is 6, decimal is 10. System which uses a combination of 10 numericals and 6 alphabets is called an hexadecimal system. Hexadecimal system. So in general, in our Maculae education system, we use these systems. One is binary, one is octal, one is hexadecimal, and another is decimal system. These are the most generic base systems that we use in our day-to-day life. There are so many other base systems, but with respect to our syllabus, we will restrict ourselves to binary, octal, hexadecimal and decimal system. Binary means 2 digits. What are the 2 digits? 0 and 1. Octal, 8 digits. We will start from 0, so we will end with 7. Hexadecimal. Hexa is 6. Decimal is 10. 10 plus 6. 6 alphabets we will use and 10 numerical values we will use. Total 16 we will use. Hence the name hexadecimal. Decimal, there are 10 digits. They are from 0 to 9. So entire, totally key point 1. Key point 1. Key point 1. First write down this key point 1. If I take any base system K, K could be any numerical value beta. There will be digits from 0 to k minus 1. Please remember this. If I take a base system k, base system will use only few digits. What are the digits that it will use? It will use the digits from 0 to k minus 1. 0 to k minus 1. If k is 2, digits will be 0, 1. If k is 10, digits will be from 0 to 9. 0 to 9. In a base system k, there will be digits from 0 to k minus 1. Decimal. I will call decimal and I will call all this as a non-decimal. One is a decimal and another is a non-decimal. What are these non-decimals? Non-decimal will be binary, or it could be octal, or it could be hexadecimal, or it could be any of the other base systems. Please write down this. Any of the other base systems. So basically these are the 4 types which will be there in all the textbooks. One is a decimal, another is binary, another is octal, another is hexadecimal. Another is hexadecimal. Now conversion from non-decimal to decimal. That means the question will be in non-decimal. Decimal means it is base system 10. First we will see the concept. Then we will take a problem. Decimal means it is base system 10. Decimal means it is in base system 10. Deca is base system 10. Suppose one example. I will take 2 examples. Suppose 2, 3 is there. 2, 3 is there in base system 10. 2, 3 is there in base system 10. Even though it is 2, 3, we call it as 23. Why we call it as 23? Why? Because 2 is there in tens place. 2 tens are 20. 2 is there in tens place. 2 tens are 20 plus 3. 20 plus 3 is 23. 2 tens are, it becomes 20. 20 plus 3. 20 plus 3 is nothing but 23. That is the reason we call it as 23. Why we call it as 23? Because 2 is there in tens place. The value of 2 will become 2 into 10, 20. Suppose another example. 174 in base system 10. 174, once it is represented in base system 10, we call that number as 174. Why we call it as an 174? 4 is there in units place, 7 is there in tens place, 1 is there in hundreds place. 1 is there in hundreds place. So the value of 100, 1 became 100. 1 into 100 is 100. 7 is there in tens place. So 7 became 70. 4 is there in units place. So it became 4. 100 plus 70 plus 4. This became 174. 174. Now what did you understand from this example? This example is not talking about only in decimal system. So if 2, 3 is there in base system 10, what is that we have understood? Start from the rightmost. Start with the base power 0, base power 1. This is base power 0. This is base power 1. Because the base is 10 here, it became 10 power 1. Suppose 174, start from the rightmost. 4 will take the base power 0. 4 into 10 power 0. Go to the next rightmost. 7 is there in the tens place, or the second digit which will come after the rightmost place. 7, second digit, give 10 power 1. Third digit, give 10 power 2. Because the digits are taking from 0 to k minus 1, start with base power 0, base power 1, base power 2, base power 3, and it continues. Again, I am repeating this important point. Otherwise, you will just blindly go ahead with the execution. Now we will solve this problem. He is saying this is 514 in base system 9. I want it in base system 10. My logic is very clear. If it is in base system 10, I will start from the rightmost, keep on putting 10 power 0, 10 power 1, 10 power 2. Same analogy holds good for a non-base system. It is in a base system 9. If it is in a base system 9, I will start from the rightmost. I will start with base power 0, then base power 1, and then base power 2, then base power 2. So this is nothing but 9 power 0, 9 power 1, 9 power 2. 5 is a digit. A digit will have a value because it is kept at a particular place, right? A 0 does not have any value. A 0 does not have any value. The best part about 0 is you keep on putting a digit before 0, the value of the digit grows. 1 became 10, 2 became 20, 2 became 20, 3 became 30. 0 does not have any value. You keep a value, you keep a numerical value before the digit which does not have any value, the value grows. The value grows. The value, that is the beauty about being 0, beautifully said by Aryabhatta. So base power 0, base power 1, base power 2. So this will become 9 square into 5 plus 9 power 1 into 1 plus 9 power 0 into 4. 81 into 5 is 405. 9 into 1 is 9 plus 4. 405 plus 9, 414 plus 4, 418. 418 base 10. So the value of 514, do not call it as 514. If you are calling it as 514, you are telling that the digit is in decimal system. That's the reason, extremely careful. 514 in base system 9 is equivalent to 418 in base system 10. But if this is given in the examination, this is the traditional method how you are going to solve it. There has to be a reason why you have to attend my class. If I do not add value to you, the subject which you already know, then it's of stupidity for you to attend my class. My class should add value to you. Because I add value to you, you should listen to the class with 0 deviation. Right? There are certain people who does not even, right, realize the importance of getting surrounded by, right, the people who got knowledge. 514. But if this is given in your examination, 514 in base system 9, what is the answer we got? 5 into 9 square, 1 into 9 power 1 and plus 4 into 9 power 0. This is 405 plus 9 plus 4, which is 418 in base system 10. Suppose if in the question it is given as 428 in base system 10, 418 in base system 10, 318 in base system 10, 328 or 338 in base system 10. If this is options that is given to you, one is method 1, conversion method. Another method is method 2. Listen carefully. Absolutely interesting understanding of this question. Suppose if I add 9 to a number, 23 plus 9 is 32. 23 digital sum is 5. 32 digital sum is also 5. 41 added 18 to it, which is 15,9. 41 digital sum is 5. 15,9 digital sum is also 5. If you add 9 or multiples of 9 to a given number, digital sum of that number will not change. I am repeating it. If you add 9 are multiples of 9 to a given number, answer digital sum will not change. This is multiple of 9. This is multiple of 9. 9 power 0 into 4. 1 into 4 is 4. Answer digital sum should be 4. Answer digital sum should be 4. Are you all with me? 428. 4 plus 2, 6. 6 plus 8, 14. 14 digital sum is 5. Not possible. 8 plus 1, 9. Digital sum is 3. Not possible. 8 plus 3, 11. 11 plus 3, 14. 14 digital sum is 5. Not possible. 8 plus 1, 9. Removed. Remaining it is 4. Without even converting non-decimal to decimal, you can eliminate the wrong answer options because of the unit digit given. Because of the unit digit does not take any base into, unit digit will take base power 0. So because I got 4, 4 into 9 power 0 is 4. Answer digital sum should be 4. Keep an eye on the answer options. In case if you got more than one answer option which has the digital sum 4, use this approach. Listen carefully. The digital sum which I discuss in decimal system, you will understand in session 2 or session 3 how the answer options easily you are able to solve. I hope it is clear. Second question. 3b7 base 12 into base system 10. Whenever we are converting non-decimal to decimal, we will do base power 0, base power 1, base power 2 and so on. We will move from right to left. We will move from right to left. 3b7 in base system 12. So this is nothing but 12 power 0. This is nothing but 12 power 1. And this is nothing but 12 power 2. One way to do it is 3 into 12 square plus b. What is b value? A is 1 0, b is 1 1, c is 1 2 and so on. b is 1 1. 11 into 12 power 1 and another is 7 into 12 power 0. Are you all with me? One is you are extremely good in mathematics. What you will do is 144 into 3. 11 into 12 is 11 into 11 into 12 power 1 which is 132 and 7 into 12 power 0 which is 7. So which is 432. Slowly you will start doing like this. 432 plus 132 plus 7. 430 plus 130 is 560 plus 2 plus 2. 560 plus 4 plus 11. 571. 571 you will do like this. 571 you will do like this. You are Anil Nair students. You are the special ones when you are writing competitive examination. Every Tom, Dick and Harry will solve like this because our teachers taught like this. 432. I want my kids to be sharp. I want my students to be little more intellect. First thing what I will do is, right, 12 is divisible by 3. 12 is divisible by 3. 7 when divided by 3, remainder 1. Answer when divided by 3 should give remainder 1. Finish. Are you all with me? 12 is divisible by 3. 12 is divisible by 3. 12 is divisible by 3. This 12 is also divisible by 3. 7 when divisible by 3. 3 2s are 6. Remainder 1. Answer when divided by 3, it should give a remainder 1. 5 plus 7 is 12. It is divisible by 3. Remainder 1. I will take as many questions as possible. Suppose if it is 1, 2, 3 in base system 5 converted into base system 10. What I will do? This is nothing but 5 power 0. This is 5 power 1. This is 5 power 2. 1 into 5 power 2. 2 into 5 power 1. 3 into 5 power 0. I will be an idiot to solve this equation and do it. This is divisible by 5. This is divisible by 5. 3 into 5 power 0 is 1. Answer when divided by 5, it should give a remainder 3. Are you all with me? Answer when divided by 5, it should give a remainder 3. I can keep on taking as many examples as possible. What I will do is, this something beyond unit digit is irrelevant to me because all are divisible by 5 power 1, 5 power 2. This unit digit is important to me. That unit digit is important to me. For example, 342 in base system 7. Directly my student will say, this is divisible by 7 because it is 3 into 7 square, 4 into 7 power 1 plus 2 into 7 power 0. This my student will not even solve. Answer when divided by 7, it should give a remainder 2. Are you all with me? 121 in base system 4 in converted into a decimal system. I don't want anything beyond unit digit. Answer when divided by 4, it should give a remainder 1. This is an acid test which you should perform before you solve the traditional method. Then you will understand mathematics has evolved. I will tell you one-to-many function. One-to-many function. One-to-many function. Then you will understand it very clearly. The only operator which is in mathematics is plus. There is no other operator in mathematics other than plus. 2 numbers addition, 3 numbers addition, 4 numbers addition. Addition has got evolved into. Plus into. Right? Into is nothing but a superset of plus. Into is nothing but a superset of plus. If I keep on doing plus, superset name is into. Are you all with me? Superset name is into. If I do negative addition, minus, I get division. If I do into, I get power n. If I do division, I get power 1 by n, which I call it as a surd. Are you all with me? Which I call it as a surd. This is an element in the set, or which is an subset. This is a superset. To convert from subset to superset, there is a small element in the set. I want to know the behavior of all the elements in the set. I use a derivation. D by dx. If I want to convert from superset to subset, I will use integration. I am sure you agree. Some curve is there. I want to find the area of the curve. What do you mean by area of the curve? Area is nothing but a circumference of all the points which are present in that circle. Are you all with me? Right? For example, x square is there. If I do d by dx, which is nothing but 2x. This example is enough for me to understand it. X square is multiplication. Multiplication is superset. 2x is addition. Addition will result in multiplication. Are you all with me? Right? Or in other words, d by dx is for to get a superset. To get the subset, it is 2x. Why am I saying this? I am saying this because non-decimal to decimal, if I multiplied with bases, to get decimal to non-decimal, I will do the reverse of multiplication, which is nothing but the inverse of multiplication, which is division. Multiplication and division are inverse functions. Because I am doing the inverse of this, I will do division. Non-decimal to decimal is multiplication. Decimal to non-decimal is division. Now see here. Now listen carefully. Convert the decimal numerical 65 to base 3. 65, I need to do division. 3 21s are 63. Remainder is 2. 3 7s are 21. Remainder is 0. 3 2s are 6. Remainder is 1. Go division till you get a number which cannot be further divided. 2 cannot be further divided. So 65 in base system 10 is nothing but 2102 in base system 3. In base system 3. Are you all with me? 65 in base system. 65 in base system 10. In base system 3 is nothing but 2102 in base system 3. Anil sir, I do not understand this mathematical definition. Make it simple. Make it logical. Go from the reverse. If I have to convert from here to here, what I will do? This is 3 power 0. This is 3 power 1. This is 3 power 2. 3 power 3. All these are divisible by 3. What is remaining? 2. Answer should, when divided by 3, it should give a remainder 2. 6 is divisible by 3. 5 when divided by 3. 3 ones are 3, remainder 2, which is 3k plus 2. Are you all with me? You don't need to mug up how to convert from non-decimal to decimal. If you understand the basic definition of using base systems. Are you all with me? One more example which we will solve. Are you all with me? One more example which we will solve. Convert the decimal number 127 into base system 5. Convert the decimal numerical value 127 into base system 5. 127 in base system 5. Non-Anil Nair students will solve like this. They think that everything is available in textbooks. Even textbooks can also be questioned. 525s are 125. Remainder is 2. 5 5s are 25. Remainder is 0. 5 1s are 5. Remainder is 0. I will go till the value 127 in base system. In base system 10 is nothing but 1002 in base system 5. Are you all with me? Base मेरे को कुछ भी नहीं करने का, मेरे को ये समझ में. If you are a non-mathematical student, first of all, you will ask me so many questions. Why should I take from remainder? Why should I do from bottom to top? I am not even understanding. If you are not understanding, forget this logic. Go with Anil Nair logic. If it is 2, 5 power 0, 5 power 1, 5 power 2, 5 power 3. All these are divisible by 5. Remainder is 2. My 5a plus 2. 5a plus 2. Just check it out. Right? This is nothing but 1 into 10 square, 2 into 10 plus 7 into 10 power 0. Are you all with me? This is divisible by 5. This is divisible by 5. 7 when divided by 5. Remainder 2. Or in other words, divide 127 by 5. 525s are 125. Remainder is 2. Right? These are some things which are not regularly taught in our school days. Because at the age of 13 or 14, there is a certain level of competency that is required to clear that examination. I hope it is clear.